Welcome to my channel, dear friends. And here is the problem of integration, double integration. And this problem is posted by uh, K. Srinivasa Raghavan to the magazine, that is the Romania Mathematical Magazine Group. Okay, so this question is posted by this mathematician, and I am the solver here and solve this problem. See the technique of solution. Uh, Let us assume that this is an I. This is 0 to pi by 2. This is 0 to, this is 0 to infinity, 0 to infinity, and root x and dx and dy, and whole divided by x cube, x square, x plus 1, and xy whole cube, and xy whole square, and xy plus 1. Okay, I can write 0 to pi by 2, and this is actually root x by x cube, x square, x plus 1. Okay, and here is 0 to pi by 2, and this is your dy, and divided by xy whole cube, here xy whole square, here xy plus 1. See, now I am using some technique to solving this problem. See here the variable, let us assume this is as a whole like z, x, y, whole thing as a x, y. So in that case, here is a variable is y, but x is constant. So that's why multiply 1 by x and write here ddx of xy. Okay, since here is a x is constant, so derivative of xy is x into dy actually. So x into dy balance with x, so it will be cancelled by x. Okay, and also here dx. Okay, since let z is equal to x, y, and this is z, since this is x, y, this is y actually. So the limit is 0 to, this is infinity. I have wrongly written here, this is infinity, and 0 to infinity. If we put here 0, then we got 0. Put here infinity, then we got infinity. Okay, so I can write here 0 to infinity root x by x cube, x square plus x plus 1. So these are simplify, then it would be 1 by root x here, and again 0 to infinity, that is dz. See here 0 to infinity dz, and this is here z square and z cube and z plus 1. Now factorize this figure like z cube, z square, z plus 1. Take common z square from these two. So this is your z plus 1 here, z plus 1. This is your z plus 1 into z square plus 1. Okay, and this is your dx. So 0 to infinity dx by root under x, and if we factor this, like we get that is x plus 1, and this is x square plus 1. Okay, and now for that, this is here dz by z plus 1 and z square plus 1. Okay, so Now find the value of this integral from 0 to infinity. Multiply by 1 minus z here. So this is okay. So you got here z square minus 1 and z square plus 1. See, this is 0 to infinity. We can write here z minus 1. This is z square minus 1 by z square plus 1 and dz. See, if we take LCM, then the LCM value is this, but here is 2. So for balancing, we want to multiply by half. So this is a 0 to infinity. So z minus 1 by z square minus 1 and dz 0 to infinity. This is dz by z square plus 1. Okay. So from this, where is, we can write here, this is ln mod z plus 1. ln mod. Okay. This is wrongly multiplied by z minus 1 also and dz. And this is dz by z plus 1. This is ln z. And this is here 0 to infinity. Okay. This is 1 by half 2z dz by z square plus 1 plus dz by z square plus 1. This is ln mod z plus 1. So this is here half of ln mod z square plus 1 and this is tan inverse z. Okay. Actually this is 0 to infinity, 0 to infinity, 0 to infinity. So whole thing is 0 to infinity, limit is this. Okay. So for that, half of this is ln mod z plus 1 whole square by z square plus 1 and tan inverse z. This is from 0 to infinity and this is 0 to infinity. Okay. For this limit, actually this is 0 and this is pi by 2. See, if we want to put here infinity, so within the modulus take common z square. So within the bracket we got here 1 minus 1 plus 1 by z. Z square is cancelled. We got here by 1 plus 1 by z square. As z tends to 0, so infinity, so 1 by z equal to 0. So for that, this whole thing is log 1. So we got here log 1 means 0. Minus, put the lower limit directly as z. So we got here log n also 0. So whole thing is 0. So 0 to infinity. So put here tan inverse infinity and that is pi by 2 and tan 0 is 0. So the value of this limit is equal to pi by 2. Okay. So here is calculation. Now multiply by here pi by 2. And now let us assume for this integral, let, and this is x is equal to p square. So dx is equal to 2p and dp. So this is there. If we put the limit 0, then we got 0. Put the infinity, then the value of p here is infinity. Okay. That is twice p into dp and whole divided by, this is here p, for that p square plus 1, for that p to the power 4 plus 1. Okay. This is 2 is cancelled and p are also cancelled. So this is here okay. Also some mistake here. This is multiplied by half. multiply by half. Okay, so this is here by 4. Okay, and this is actually 1 by 2, 1 by 2. So this is equal to pi by 4. This is here 1 by 4, take on 1 by 4 actually. Okay, this is pi by 4. So this is here pi by 4. 2 is cancelled here. So this is pi by 2. pp is cancelled. So dp and 0 to infinity. Okay, multiply. Here is p to the power 4 minus plus 1. So we want to get here p to the power 4 minus 1. So multiply p square minus 1 into dp. And pp is cancelled. So this is p to the power 4 minus 1 and p to the power 4 plus 1. This is pi by 2. Now this is 0 to infinity. And now p square minus 1. And doing as a partial fraction, p to the power 4. This is a p to the power 4 minus 1, p to the power 4 plus 1. And this is dp. This is a pi by 2, 0 to infinity, and multiply by, now within the bracket, p square minus 1, p to the power 4 minus 1, and dp 0 to infinity, p square minus 1 by p to the power 4 plus 1, and dp. Okay. Now this is pi by 2. For that, this is 0 to infinity, and dp by p square plus 1. Okay, and for that 0 to infinity divided by p square, then 1 minus 1 by p square. So this is a p square plus 1 by p square, and this is dp. This is pi by 2. Okay, this is pi by 2. This is tan inverse p. This is 0 to infinity minus, this is 0 to infinity, and derivative of p plus 1 by p. Okay, so for that we want to write p plus 1 by p whole square minus 2. So you can write root 2 whole square within the second bracket. And this is equal to here pi by 2 again partially. Okay, partial fraction. So we want to get here 2. So balancing, this is here 4. Okay, this is here by 4. Okay, now put here infinity, then we got here pi by 2 minus, and this is 1 by, the integral result is 2 root 2 ln within the bracket p plus 1 by p minus root 2 by p plus 1 by p plus root 2, and this is 0 to infinity. Okay, see, for this value is actually 0. Why? If we take common p from numerator and denominator, then we get here pp are cancelled, then we get here 1 plus 1 by p square minus root 2 by p, same as 1 plus 1 by p square plus root 2 by p. Since p tends to infinity, so 1 by p equal to 0. So we got here log 1. You know log 1 is 0. Again, if we take LCM of p, then we got here p square plus 1 root 2 into p square plus 1 root 2 into p. If we put 0, then we got again log 1. So log 1 is 0. So whole thing is 0. So we got the answer pi by 4 into pi by 4. This is pi by 2. This is pi square by 8. And this is your answer. I think all of you better understood. Okay. If you enjoy this video, then share this video to all your friends and don't forget to subscribe my channel. Thank you everybody.